Shoot.
Hi.
Good.
Good. Little bit. Very chance to start the meeting. I would have started.
Yeah. Good.
Okay. I think I'm on, but it hasn't dialed on yet. Oh, there he goes.
Oh, Aaron, can you hear me?
Can hear you.
Excellent.
Yep. I'm going to pass the ball to you so you can load up your presentation. Control.
Now the presenter.
Yeah.
And do I mean
My desktop?
share my desktop? Yep. There
we go.
And now this is a idle screen here. Is it sharing my presentation or my blank screen?
Presentation.
Excellent. Okay.
So
Dual screens before. I think you're seeing my presentation, aren't you?
yeah, on your presentation.
Okay. I got the light notes off to the side and everything. So I think this is set up good here.
Okay.
You guys use 5:10 after or something? Or?
Yeah, probably give everyone a few minutes. I'll just send a line.
Okay, I am good.
Great. Okay.
Record and archive these?
We don't do a great job of archiving them anywhere. As this proprietary format, and so the barrier to the archive is transferring it to something that's more shareable. Do a better job, but it is recorded, so we can do the link afterwards. Are you this week?
I am.
Is there yet?
I mean, for the last 5 days. There's going to not rain today and then start raining again for 2 or 3 days. things are starting to bud out, but now we're in that kind of zone of worry where it gets down into the 30s at night.
Yeah.
If it dips evening, we may not have cherries. So, how are it there?
It's been kind of cold. We're fine to the 50s and 60s.
Our highs too.
Snow lately, so. But I think this week goes 3 into the 80s.
Oh, nice.
Yeah.
I got all registered for the hotel and everything.
Today, and I was on hold for 5 minutes and didn't ever get a person. The resort is closed between now and next week, and so if you don't get a response,
I'll supposed to do it by the 5th.
I may revise that based on the fact that I called today and didn't get a response. I'll try this afternoon. You one more minute, and we'll get started.
Look, you can start whenever you're ready.
All right, sounds good. First, thanks for the opportunity and to talk about this. It's always kind of fun to talk about some things that you've been working on, especially if you get a chance to rant and rave about it. Mostly rant. It seems more fun. My name is Doug Fills. I'm a data manager with Consortium for Ocean Leadership. I am assigned to the Scientific Ocean Drilling Group and Leadership, and through that I work with IODP. And so let me just give you a little context about who I am. So IODP is the current incarnation of the NSF-sponsored sea drilling efforts. So it's the International Ocean Discovery Program right now. It's approximately 40 years of legacy in sea drilling. Just a deep sea drilling project, DSDP, that became OP, the Ocean Drilling Project, and the Integrated Ocean Drilling Program, and now the International Ocean Discovery Program. The ship that we have, this effort, that's sponsored by the National Science Foundation, is the Geordi's Resolution, that we call it. It's approximately 20 stories tall to the top of the derrick, probably 140 meters long, or about 2 football fields in length. It has a crew of 47 on board operated. In that, then, there's a science party for each expedition that takes place. That science party is approximately 20 or so scientists, co-chiefs, things like that. And so expeditions then typically run 2 months, and we operate anywhere from usually on 4 or 5. It would be nice to have the ship operational continuously, but we don't normally have the funding to support that many expeditions each year. Context, the data that we're working with in the DSDP, ODP, and early IODP efforts, the data into a relational database, an Oracle database called NES. Now we use a system called LIMS. And LIMS, even though it's stored in an SQL system, is non-relational, more of a key value store system. So we have both legacy data and then the data. Imagery that's taken on all the cores, so the ship drills beneath. So we're actually drilling cores in the sea floor. And though we're an ocean project, we're really a hard rock geology effort, not a water column effort. We pull the cores up from below the surface. The core is cut in about 1.5 meter sections, and then high resolution imagery is taking that core half, and we take a high resolution picture of the split section, and then what we call whole round or the image all the way around. We're taking on these, so we also have a sample database, a relational database, the sample and the kind of sample it was, whether it's thick or volume or the section or things like this. And if there's sections, then we have additional high resolution imagery as well. We call downhole logging. So the core, like you see off to the side there, taken, once the drill string is pulled out of the hole that we create, we sensors down the borehole. And sensors then take log, so the sensors drop all the way to the back, and then we log on the right back. And those log files then stored as well. So we have metadata stored in a relational database, and then the log files themselves, the readings themselves, they're stored as individual files with data sets. The limbs are managed, and the ship itself is managed by Texas A&M University of Cameron. The look information is managed by the Lamont Doherty Earth Observatory out of Columbia University in New York. In terms of exposing this data, mostly it's exposed through RESTful type APIs or Web Forms interface, Web 2.0 type, just simple forms interfaces where people type in metadata associated with what they're after. Cruise edition, maybe a particular physical property that they're looking for. We have approximately 20 or so instruments that run cores, and so these would be things like magnetic susceptibility, density, velocity, things like that. In addition to the high resolution, we have more specific things like chemistry, isotope measurements, and things like that that are done. So approximately 20 or so different measurements we're taking on this. And that's important later on as we talk, because a lot of heterogeneous measurements for different types of scientific endeavors taking place on the cores that are coming up. Core data is returned to the as just simple CSV or tab separated type document, some XML. We do ISO 115 type metadata that goes along with these, except for the work that Bob has done with metadata with the log files. And we don't currently use data DOIs either. All these are things that we're endeavoring to alter. Through publications, of course. The program does publications for the scientific prospectus and cruises and things like that that are, of course, tagged with DOIs and normally are the pointation for any of the derivative papers and things like that that are done by the science party. But we really are trying to improve that in terms of citable data through DOIs and other mechanisms. Good one there. And on the motivation that took me down the line of structured data for this effort, we're only with post-moratorium data for the purposes of this talk. All the data that's collected on the ship is given to the science party, and they have a 1-year period for them to publish on data. After that 1-year period is up, then the data is published, and that data then can be accessed both from websites at Texas A&M and Lamont Doherty. Again, that's mostly though just through Web Forms APIs. And one of the problems that we had is that it was very difficult for people to discover data or know what data they wanted to find, because pretty much had to know what it was, what its scientific goals were, or what the observations that were done by that they were, and then know maybe even at a site level what they wanted to access, or they to actually access a huge amount of data and sift through it themselves. And so this is the problems is that there was some obvious created from people who weren't part of that kind of community of people that utilized the facility, or specifically people who were on that particular science expedition, that particular cruise, to know exactly what that kind of information was there. Some tool integration, but mostly for operations. And so things like real-time monitoring of various physical properties as the core is being recovered. So a couple of years, 2 or 3 years ago, we were really motivated to start looking at how can we improve discovery, publication, thinking, internal amongst the data we have ourselves, and also then derive data, right? Because a lot of our data goes external, ends up in facilities like GDC or the GDC IMLS, Marine and Industrial Geosamples Database, with information in IDEA, have magnetics information in MAGIC, and taxonomic information from the paleotaxa data in various locations. And so even the canonical source for that data, it gets pushed out into community databases, more domain-specific databases, which is very proper, but there's that connection to the authoritative source can get lost. Had a lot of different ways to kind of address this. We looked at improving this we had in place. We looked at NoSQL type KV systems, key value source systems, and we kind of landed on the open data 6 small less semantic as something that we felt was the kind of functional behavior that addressed our needs, right? Linking data, operation, the concept information so that people could understand the kind of measurements that were taking place, definition of taxa and what they meant. And it was driven mostly by the desire to cross resources. And so we had genius observations across common objects, right? Which really is that we had things like cores and souls and things like this, but then had a myriad of derivative products for them, whether they were high-res imagery, physical property type things like magnetic susceptibility or natural gamma ray or things like this. And also then potentially down the stream, things, publications and stuff, which were associated with those samples, or those measurements. So looking then at dataoceandrilling.org to see how would we implement linked open data and semantic patterns in this. This is a sandbox effort, but kind of almost like a 20% project. But we knew that it's something we needed to try. And we knew we needed triples, right? So we had our data in these kind of real environments, even if they were KV type based systems, and we needed to get them in the triples. So usually what we did in the Annis and LIMS databases is we simply wrote some ETL code, right? Some extract, translate, and load code. Some in Just, some in Go. And extracted through SQL queries and then translated into triples, into RDF triples, and loaded them into our triple store. With that testing settled on Virtuoso as our, but some other very good ones like Parliament and others that are good ones. And of course, some of the capacity in the landscape has evolved since we started this effort. So we also use things like DDARQ. Barco has used that to expose the log PD data, and I've used it on some legacy databases for the Chronos.org website. So, the beauty of the ETL code, and you get, of course, very fine-grained control over what you're doing in terms of the triples and creating them. But there's the overhead of the time involved in something like that. DDARQ is a mapping of your relational tables into a tool store, into a resource or class, RDS. And that works nice. You don't have quite the control that obviously you could get with something like an ETL. But for trade-off, and especially if you have a very simple schema, then DDARQ is very efficient. Games are not simple schemas by any means, and so the option there really wasn't quite as good. That we needed vocabularies because we were developing triples, but then we had to define things like a, which is a cruise for us, a site where we drill, a core, a section of a core, a sample, a particular type of measurement that we would take, anything that we wanted to do. And started this 2 or 3 years ago. There weren't a lot of vocabularies for these types of things. Changing a little bit, we have things like the ocean ring building block. We have NERC out of England. We have a lot of other vocabulary that are starting to come up because people are starting to use things like scoff and others for these types of work. And so, one of the issues you have is that you want to try and produce as few vocabularies as you can, right? Because anything you produce in terms of vocabulary, you're responsible for. And if it's you're going to be using a linked open data process, then you're responsible for publishing it, making it, versioning it. And so, the effort here is to not make too much work for oneself and to reuse vocabularies that already exist. There's not really vocabularies in existence for things like scientific ocean drilling. So at some point, you do have to create those types of things. We settled on utilizing SCOFs for our vocabulary environment, both like OWL or simple or things like that. You can fall into quite the religious war, or hate, I should say, when you're talking about things like OWL and SCOF and taxonomies and things like this. We wanted something that was relatively easy to implement, especially because this was a test sandbox, and wanted something that we could link into a linked open data type environment, using stuff like that. So this was where we settled in terms of vocabularies. If there was something that I would go back and do tests, it would be to be far more attentive to the creation of those vocabularies, because it becomes very easy to just start fleshing out terms from your schema and creating namespace and dropping it in there, and not really spending a lot of time thinking about the implications of those terms and how they lead things like connections between data concepts in your schema. And perhaps it's a catch-22 because at the time you don't understand how RDF and Sparkle and linked open data and these types of things operate, and so you can be blindsided by that a little bit. But I would that was one thing I would redo. I'd be a lot more attentive to how we created those vocabularies. Allow other people to create established vocabularies for concepts like cruises and ships and things like that. And things you have to look at then, how exactly do you create new vocabulary coming down the line? If I try and connect the concept of a leg to NERC's concept of a cruise, we have to be attentive to how we're going to be doing that and breaking things. That's the work that we're doing internally, because it's what we're doing is serving our needs for tests. But if you start looking at this as a foundation that efforts can do, more advanced efforts that might try and come along with these nerves or things like CrossFit, you want to make sure that you enable that, even if it's not something that you are going for internally. The issue of kind of the master data management, because it's easy to do if you get everything into a label system and you're publishing through D2RQ, but you're going to have that constant publish mechanism through the templates that you've established. So ETL pipeline for these types of things, the data is actively flowing into your relay system, then keeping your triple score up with that important, right? And now there are some things that are available in flows like Hadoop and others that can do these types of things. You can also your workflow type environments that exist that you could pipe ETL code into and have run, whether it's just scheduled runs or tripped by events or things like that. But one thing is that if you're going to have, like we do, a system kind of optimized for the ingestion of the data from the instruments on the ship, that's not your primary mechanism out into the web architectural space, then being that connection current between those two is something that in some ways comes down more to policies and procedures than technology. But again, it's something to kind of watch for. Data, at first it was exciting because we're a measurement-based type system. So you might have an entire kilometer core from below the seafloor, right? So that's not an uncommon recovery that we would have from a drill site. You can imagine that when we're taking natural gamma or magnetic susceptibility readings or things like that we're getting thousands of these readings for every meter, right? And so by the time you get to a kilometer, you've got huge volumes of readings taking place. Log files or stuff like that, we typically in the past, and normally we have the community with them, done data sets, right? So we have metadata associated with those faults that you put into a triple store that then point to a data set collection that can be downloaded and utilized. Visual measurements for the observations taken on core, you could end up with millions and millions of triples just for each individual site. And so that's fine. There's not a lot of problems with the triple stores dealing with that. But, it can call when you're trying to put EOIs or you're trying to distribute that as something that's citable and referenceable by people. And so discovered that the use of the RDF data cube vocabulary was highly useful. Allows you to create dimensions in your data along the lines of the types of observations and measurements being taken, and then create this through the data. And those then become almost like a data set. They can have a land page, they can be citable, they have triples that are associated with them. And the problem you have when you start running into a situation where you might have 250 million triples, searches on these types of things not always very performant. Probably due to the fact that, of course, I'm not a semantic expert or I'm a data manager, and so I'm sure that the structure of how we put some of this data into the triple store has been less than optimal. But it's a lot of time to do the best you can, especially if you're doing free regex searches on things that were very bad in some of the triple stores, although they're getting far better in terms of how their performance is becoming. But the vocabulary was very useful for us because it really allowed us to take a huge number of those triples and not map them and deal with the data, quote, air quote, metadata around the individual dimensions of the cubes, the size of the data cubes. And so again, a really nice thing that really help performance and comprehension of just huge volumes of triples from measurements. And Spatial is still evolving. GeoSparkle and others, and they have some very nice features, but it's still an evolving area. No clear winner, I don't think, has been sketched in the geospatial aspect of this, although it's a very interesting and powerful of linked data in that regard. You get a Spark point with your triple server or your store, and it's very easy to say, oh, I have a Sparkle endpoint. I'll just give all my tool developers that Sparkle endpoint, and you go. But of course, that's not really. It's easy to say, but it's not nice to say because typically Sparkle is a new language. It's a very nice language once you get onto it, but it's not any different from SQL. So you're not bringing your SQL skills going into that world. And it gets a little difficult at first on how to understand the vocabularies as mechanisms to navigate through the data through Sparkle, because when I was working on some of the phases and tools, I developed a mechanism by which I could assay a particular graph in our triple store and get a mention of the various vocabulary terms and classes and things like that are utilized in it within a few minutes. It was kind of learned and be transferred to the tool developers if they're going to actually utilize the Sparkle endpoint. Early data manager might sit there and say, "Oh, this removes any need for aids. We can just have them use a Sparkle endpoint." But it's really not the case. There's a lot of power in that endpoint. APIs, RESTful API, with both using. So you really haven't reduced your maintenance in that regard, right? You really haven't increased a little bit. Managing a Sparkle endpoint is fairly trivial, right? Because it's just something that's just a query interface into your triple store. to exchange formats because most of the triple stores do things like JSON or CSV, TSV, convert to things like KML or other GML applications or GML applications in general, like JML or things like that. Is fairly straightforward. So one of the things in terms of what is provided was like that, right? It did improve the agility of working with data versus SQL, I felt, once you got familiar with it. Really when you were trying to connect between different areas, graphs, right? So if we had graphs that were associated with an expedition, and graphs that had information about samples or a particular physical property measurement like susceptibility or core imagery or samples that were taken on core, it was very easy to blend these things together, and I'll show that here in a few pictures in just a little bit. Thing was just nice is that, of course, current Sparkle points, if they're at the 1.1 version of that now, by federation, right? So some of the groups in the community are like BecoDemo and R2R, so that we see Chandler and Bob Arco, Sparkle 1.1 endpoints, VentDB and others. So you can actually start to federate across these data sources easily and without a priori communication, right? And it's a very powerful thing. It's one of the things that kind of speaks to this desire to be able to cut across multiple data, to cut off different types of domains, and to integrate data. It's really exciting to see that kind of capacity. And you mentioned the already have data cubes and the fact that they also kind of as a gateway to doing systems and DOI, even inside large triple stores. A little bit about data integration. The one thing I just wanted to really show with this is that the data, pardon me, on the page came different Sparkle endpoints, right? So there's one that we set up here with the drilling.org and the inter-ridge vents data, and then the IMLGS Sparkle endpoint. And so it was really interesting to utilize this. And what also the things that the vent fields here that are used are actually used then to search through the drilling data. And so I was looking for, data that was in a certain distance from a particular event. It was really interesting because it meant that I was actually using a third party's data sets to display information out of my own data set. And that was really interesting to me. I really enjoyed setting up this experiment and seeing it work. We have viewing options, so it's very easy to transfer things like pivot viewer type environments or time scale type environments. And if I chance here, time-wise, I'll show those at the end. Now, one of the things that so far, I haven't really been talking about open data. We've been talking a lot about triples and Sparkle, but that isn't linked open data. We really attach those types of concepts into the actual web architecture of pages and the representation of those pages inside web. That's when we start talking about linked open data. Our own code built in Google's Go language for doing this. Again, it was because of the experimental nature of this. It gave us a lot of fine-grained control over it. There are a lot of packages for doing this, things like Apache, Momoda, and others that do this. This is your classic 5-star data, right? Put it on the web in a structured format. Have that format be open and available for anyone to use. Use URIs as resource identifiers and your stuff to other data. And so we went through the process of then pages that represented that data, also then linked the representation of that behind the scenes into the HTML DOM itself or content created a resource for a viewable version, right? So at a particular if you put it into a browser, or a particular UI, you put it into a browser, it'll 303 redirect you to a human URL for that. And if you put that in there at machine level and do a request for things like RDF, then RDF representation of that page, right? So one URI, you referenced into different views for both human and machine. Of course, the value from this is that we get improvements in things like discovery and indexing, navigation in terms of being able to navigate and follow your nose and do things like that. So, for example, if you come to a website inside here, you can go to things like the core strips. See an example of the image strips. And of course, here's all the data shared with that particular image strip and the image itself. To extract things like the samples that are associated with it. All this is collected through a Sparkle query in the back. And the Sparkle query for this basically just says, find me samples that are associated with this particular core concept, right? Of this core image that's here. But it provides this really kind of nice exploration, right? So you go from core, you can go into things like sample details and get sample details associated with that, kind of navigating through this web architectural environment. This leads to third-party tools and things like this being able to exploit those environments as well, right? So we could break out to things like core that we see down here in the lower corner that was created by a friend of Reed, Sean Higgins, if you know him. It's in front of a giant multi-display system at the Electronic Visualization Laboratory, right? So it's a big vision wall, display wall type environment, and all this type of information can be routed and extracted then because kind of web architectural capacity. So this is possible to look at, right? So we have the SQL and files and things like that transferred into a triple store through DRQ and ETLs. And then we have different types of queries and APIs, interoperability, and web-based things like linked open data or schema.org that we interface into these types of environments. We had a common founding language for collaboration. I've already mentioned groups like R2R and Vicodino, GS, there's CCAN and Visco and many others that we've worked in. And because when you start dealing with these standards like W3C standards for things like RDF, Sparkle, linked open data patterns, and things like that, since you're in a common architectural environment and a common pattern, also dealing in that pattern as well, the ability to link and connect information is just all the more enhanced by that environment. So the ability that it's given to us in that regard has been really nice. Just end here, I'd like to talk a little bit about new development. In fact, it was a year ago at the ESIP meeting that I listened to Peter Fox give a talk on schema.org data. I was intrigued with this and wanted to look at it. And part of it was because I've addressed a nagging aspect of linked open data, which was that I could expose lots of things through web architectural patterns, but unless I was talking with someone or someone explicitly wanted to go looking for that content negotiated view of that or things like that, there wasn't a lot of kind of commodity exploitation of that. And where the bigs have started working with that, groups like Google and Bing, Yahoo, and others, things like schema.org. Our guy actually, I think, was one of the instruments in pushing through the addition of the data set vocabulary within schema.org. So schema.org is a real collection of vocabulary that can be used into the source code of your HTML page. So here we have the source code, and you inject schema.org vocabularies or potentially RDFA vocabularies into something like that. So here's the SAM ID page that you see is something like this page here. And if we took that and placed it then into the web tool, and place that URL here, Google can understand how to extract structured data that's in there and understand that a key and a value for that key. Now, of course, Google doesn't probably really care too much about magnetic susceptibility on cores, right? But the data set vocabulary within schema is something that they're willing to look at and index. And by utilizing that, you can start to expose your data and keywords, because keywords are part of that, associated with that particular data set. So again, a pattern like microdata, or JSON LT, to put data into your HTML. This is very similar to what we do in like a linked open data environment. We want to inject RDFA into there as well. We're content negotiating for the URL as a machine readable rather the machine is parsing the HTML DOM. So this is parsing, not scraping, right? Because it's only looking for properly structured data that's in there. Motion, this is reporting the EarthCube end-user workshops. This was a end-user workshop technological grand challenges report created by the Arizona team. And it has several references to things like that. Engine was needed that facilitate discovery. EarthCube could provide a search engine tailored for communities, search, things like that. And we can talk a little bit about then how do you go about addressing that, right? There are lots of things that exist now. We have APIs, we have linked open data, like I mentioned. But very appropriate for some things, but not necessarily good for the type of generic discovery of information. That follow your node, serendipitous discovery of information are really active in these regards. So what we can do is we can actually use things like the schema.org data set, right? So the schema.org data set finds out things like a data catalog, place, download, and associated with that particular data set, things like third and citation and things like this. So this is to the structured data that we place then to our web page associated with something like a particular data set. And it's a subset then of the schema.org creative work environment. This is an evolving system, and of course this may fail. There's been other efforts that have tried to do things like this, like Webins and other types of efforts and micro formats haven't really come. They say there's no guarantee that this will either. Notches in it, like for example data and things like that. The date, they require that the visible date be what is a structured data markup, and that may or may not be the kind of way you want format for a date, right? You may want something that's more human friendly in terms of providing. But following the schema.org pattern, there's an ISO date format standard. And so there's issues yet with, you always want the C data to be visible in that regards. And it's Ajax interfaces and indexing. Pardon me. You could do this locally as well. So, for example, you could actually access the information and create triple stores and harvest this out of your environment. I wanted to do, just kind of as a nod to time, I wanted to show particular and really kind of convey what's going on here, kind of as a closing element to this. And that is search.appspot.com. And so this is a kind of 183 paleo geoscience related sites collected by the C4CM. And I'm here and type in things paleoclimate. Information that's only from that particular group, 183 sites, right? So it's a domain-specific search engine. This is a Google custom search, they call it. What's interesting is that you can actually interface a custom search with schema.org sandbox that I've set up. And if I do this search for just the concept of an IGSN, for example, 183 sites, you'll see I get things like of card about the IGSN and what is an IGSN. The things we would expect in PageRank type environment. This is being done across the exact same set of sites, but instead, in the configuration of the search engine, I pulled it to also preference things that have structured data, in particular, schema.org data set. When I type IGSN here over that same set of sites, the reference becomes actual sample registration. Because if I were to put more details in here, I could drill down into this. So that these are actual samples that have up then as data set types, right? So we can say type of data set, right? So this is schema.org, vocabulary.org, type of data set, right? This is very, very much related to the DCAT vocabulary if you're familiar with that. So then, when we're looking at this, is that we build these types of resources that Google's providing, and we can also do this ourselves. We can build capacity that is focused on structured data embedded in there. In particular, we can make searches that are looking only for data sets. Data sets could actually be things like this is an RDF data cube, right? So this is the direction I'm going, where I can expose now my option and measurement data out of my relational database, a data cube. What says in that data cube, dimensions in that data cube that are exposed and marked up with metadata as schema.org and discoverable through an interface like this. And since this is indexing multiple sites, you could be data sets from an entire domain that's in there. Those are the key things I kind of want to show. So I'm going to up a few things here. There are a lot of tools that are available for this from Google and others. There's some other work that people at Google have been doing in terms of the data set. The NASA Earth data, NASA.gov, ECHO, has been experimenting with the schema.org data set, and some others doing that as well. So there's some momentum behind that, but it is, as I highlight here, it's by adoption, right? If no one does this, there won't be any interest in it, obviously. Here, these are a few closing thoughts that I had, things that we could do. Things like content negotiation for JSON LD is kind of high on my interest list because it would make having a web architectural-based environment extremely fast, because you wouldn't be having to pull out of the HTML DOM. You would just be use a JSON result quickly, and then you could map that into native collection systems inside your own code. So it would be a very effective environment. And their testing will probably take place on Paleo Search app spot over here. A lot of developments that are going on. They're kind of more academic type things. They're not really things I would be doing obviously, but there are a few things I would like to facilitate be done with ocean drilling data. And closing then, I'd just like to say thanks for the opportunity to talk to you, and I'd like to also thank people like Bob Arco and Chris Jenkins, and Lisher and Ida and ESIP and Peter Falki and ESIP now too, of course, for a lot of their help and interest in this. I think it's been a very fun community to be experimenting with. And questions if anyone has.
Very much, Doug. This is Matt. I was wondering how structured and well-formed was the source data that you were dealing with. As far as, was it a well-defined SQL database? I mean, right now I'm working on a project trying to get it into the semantic web, but I'm dealing with a lot of business users with spreadsheets that are calling slightly different things depending upon their perspective. So to really, map things into a hierarchical model when you're starting with fuzzy data.
Right. So our schema were very well defined, but really optimized for dealing with the data that was coming from the instruments. Right. So one of the things that we've had to do, of course, even prior to all this testing, was that it was coming from the instrument and going into the relational database, and that was great. That's really how our customers, right, our scientists, wanted to look at it. And so to build up some logic, and they've extracted all those measurements, the observations that the scientists really wanted to be interested in. And your other comment, we had some similar issues, right, in that bot zones or other concepts within the community were often redefined for every cruise, right? The idea of what that particular strap meant, what its age boundaries were, would change from place to place, and so that was kind of interesting. One thing, and I didn't talk about here, things like RDF rules, and actually one example that was on the screen here, we did use those to meet between two concepts. Carl Moore, also thank at NOAA and GDC, had concepts in IMLGS that were completely different than what I called them inside environment. Able to create rules then that simply mapped it. When my concept to the searches of my triple story, simply mapped it to what her concept was and would include data in the Sparkle 1.1 federated query. That was really nice. It was kind of fun to see that work, and it was nice because I didn't have to tell Carla that. I could set a rule that says, well, when you access that particular resource, my concept to my concept, and just produce as though it would go forward. So, those are kind of some of the things that we had to deal with, and it is interesting as terms evolve. You'll manage that. How do you manage the creation and curation of those rules? Suppose that to someone to search, right? Because if they were to go to a site and do that search and not get the same results, and I wonder what kind of magic I was using to get those results. So those are just kind of some of the ways we've dealt with that.
Thanks. But if you're dealing with a project where you're still defining the conceptual model and a lot of even relationships and even like
Right.
this objectives aren't well defined, it's really hard to deal with goals.
Right. Also, this upper level type of stuff like you alluded to as well is difficult, right? Because you can make some kind of like what they call ontology or domain vocabulary, higher level, general ones, right? But then the question is, is it proper to generalize to that level, right? In the arts, and it is difficult. We as we see more heterogeneous come into the environment, how do you make sure that you this data that's relevant without being too broad and delivering to a particular user.
You alluded to the or necessarily being adopted by the big boys per se, and wondering what are your thoughts on how it's going to go, and give maybe the worst case scenario if it did go that way, be able to reuse some of your earlier efforts to you could take advantage of the infrastructure that is be used by or set up by the big boys.
No, that's a very good question. It's absolutely right. So you have schema.org and bluntly, big groups like Google, Yahoo, and Bing, Microsoft, probably far more interested in movie ratings and where your restaurant is than where your favorite, science data set is located. Unless, and I think through the efforts of like RPI and others, they have implemented data set. It is an accepted vocabulary now in the general schema.org, a subset of creative work. And you can use things like Google Custom Search, which is what I was showing with this interface here, and take advantage of that now. Now, that doesn't mean that some dates does not support in the future. I talked too much about this in the sake of time, but one of the things that we did as an experiment then is that sites set up implemented schema.org into their environment, right? The data ocean drilling, IDA, and the MLGS test site that's using RDF. And then as I wrote some code that had those sites, it's really easy to build website crawlers now. To be careful, I had a little joke here, right? It's like building your own little denial of service that you unleash upon yourself, right? Because you can sit there and say, I want to crawl, the website, and if you're automating information on data slices, on RDF data cube slices, for example, you might have millions of it. right? Take some time. Able to index all those sites in about 2 or 3 days as I throw things back to make sure I wasn't too onerous on those sites, and created my own graph then. And in some ways, it's an opportunity to build domain-specific knowledge graphs, right? Because you can, if people were implementing the structured data, or they were using linked open data, and that would be nice too, because you could always do the content association for that, you can actually start to build up your graph across the domain sites, right? So one could imagine a scenario, whether it's or not is arguable, but one could imagine a scenario where the paleo science community says this is a wonderful thing and starts implementing across the 200 or so URLs that kind of are the core representation of that community. And it would not be very difficult to assemble the resources, especially if you just instance them up on things like the Amazon or Google Cloud environments or some of the open compute grids that are available, and index 200 websites for structured data and build out a graph of that. In fact, there's this group, Web Data Commons, that does that very thing. In fact, Web Data Commons is they go out and they look over this common core corpus, and they act RDFA, microdata, and others from that. And you can see they've got a 40 terabyte compressed file, first URLs with structured data that's in that. And you could easily do something like this for a domain-specific environment and exploit embedded structured data, whether it's schema.org, RDFA, or anything in that regard. I hope that's a question, Bob.
Yeah, great, very helpful.
Well, very much, Doug. That was very interesting. It's a little while before data matures to the point ready to try this stuff out. Look forward to maybe in the future asking you a few questions about.
I'm happy. It's fun for me to do. So appreciate the opportunity to talk about it.
Great. Well, else doesn't have any questions, I guess that's it. Thank you, everyone, for participating.
Thank you. Good day.
Thanks. Bye.